In this video, I'm going to talk about one sample proportion confidence intervals and using our calculator to perform these operations. In a one sample proportion confidence interval, we have a few conditions. We need to make sure that our sample is random and that we are dealing with a large enough sample size. So if we're given a proportion and a sample size, we need to make sure that our sample size times the proportion of successes and our sample size times the proportion of failures is greater than or equal to 10. Our calculator will need actual counts of successes. So for instance, if I had n equals 200 and I know that my proportion is equal to 0.25, this doesn't give me an actual number of counts. This just gives me a percent. And so in order to find the actual counts, I can just multiply n times p hat to get 50. This is what we would use as counts in our calculator. In your calculator, when you're performing this operation, you're going to want count of successes, the number in your sample, and the level of confidence that you're dealing with. The formula that our calculator is using is taking the p hat, which is our sample proportion, plus or minus the critical value for the level of confidence that you're providing, and the sample proportion of successes, sample proportion of failures divided by n. And we're using the standard error here because we don't know what the true proportion is. We're actually trying to estimate the true proportion. Here's an example where we say the National Boxer Dog Survey found that 170, that's our count of successes, of a sample of 2,673 dogs were all white boxers. So we have p hat, we have n, and they ask us to provide a 90% confidence interval for the true proportion of all boxers that are white. I have the three pieces of information that I need, and so in my calculator, I'm going to press stat, and I'm going to go to tests, and I'm looking for a proportion, and it's a one sample. So I'm going to do a one proportion z interval, which is not on the first screen that you see. So you can either arrow up or you can arrow down to reach it. I want a one proportion z interval, so I hit enter. The number of successes was 170. The number in my trial was 2,673. And my confidence level for this problem was 90%, so I'm going to do 0.90. I have not checked any of my conditions. This problem does not state whether it was random or not. I didn't give you the whole background because I just wanted to show you how to work on the calculator. So it's on you to check your conditions for inference and to perform your whole four-step process. When I calculate this, I get my lower and upper bound, my p hat, which is the sample proportion, and it gives me back my sample size. So here I have 0.05583 to 0.07136, and I'm told that p hat is equal to 0.0636. So my interval here, I can make a conclusion that I'm 90% confident that the interval stated here captures the true proportion of all boxer dogs that are white. And that's it. Thanks for watching.